Next topic is relationships in ER models. So let's start with that. Yeah. So in last lecture, I asked one question in the last slide. Yeah. So the question was, suppose a student is there as an entity set and a course is there as an another entity set. So what happens is, what connects these two entities? Yeah, that was a question. So answer is a relationship. Answer is a relationship. That is our answer. And it connects these two entity sets, student and course. So how we will represent it? We will represent it with the diamond. So this diamond will help us to connect these two entity sets. Correct? So today's topic will be concentrated on this one. Why relationships are important, and to understand it more precisely, let us go further. Let's see it. Yeah. So let's understand it in this way. Okay. So here is one student given to us as an entity, and another entity is given as course. Now, right now, they are basically looking like two useless islands. They are, it is sitting here, it is sitting here. And so what is the relationship between them? This one and this one. So you have to think in that way. Correct. So you can think in certain ways. Like think about every application on your mobile phone. College portal. You can think of this college portal. Who enrolled in what? Yes. Who enrolled in what? In college. Correct. So you check that or you do that as a student. Any next one, Swiggy or Zomato. Who ordered which food? Correct. So these are certain questions that comes to our mind and which helps to develop relationship. What is the relationship with this application? What you are doing in this application? Correct. Next one, you can think of IRCTC app. Who booked which seat? Instagram, who follows whom? So every single of these ones is showing a relationship between some entity sets. So your data may be 10% of entities and 90% of the connections. So if you'll find out these connections correctly, the entire database will work nicely. That is the thing. And if you will get them wrong, entire design can get collapsed. So today we are going to see how we can connect these things and what are different constraints, what are different rules and regulations while working with relationships. Let's go further. Now we have one more term, relationship sets. Okay, let us see that. Now here, what is a relationship? First thing. So relationship is an association between two or more entities. It is an association between two or more entities. Okay. So we can think of one specific student associated with one specific course. Now, does this pattern feel familiar? Like in the previous lectures, in one of the lectures, we have discussed this one. Ravi is a student, is an entity, and so Ravi takes one course that is DBMS. So there is a relationship between Ravi as a student and a course DBMS. Okay, so this is one entity, but its entity set is what? Its entity set is course. And this is one entity and its entity set is student. What is the relationship? Relationship is takes. So that only we discussed in the previous slide also. Okay. So takes the collection of all student course pairs in the college, which will become your relationship set. Okay. So these all student course pairs will be drawn as one diamond, and that diamond will be the relationship takes. That means student takes course. That is the relationship. So in this way, we have to identify relationships for all our entity sets. That is the meaning. I hope you got some understanding of what we are going to do in this. Good. So let's go further. on this. Yeah. So this is our relationship between two entity sets, the diamond. Okay. So this is a shape for representation of relationship in the ER model. So relationship set will be drawn with diamond. It will sit between the two rectangles, which will represent entity sets. Yeah. Now, there are some rules that we have to think. This diamond will always sit between rectangles. It will never go alone. Okay, you cannot just show diamond somewhere and you are not connecting it anywhere. That is not allowed. So it will never float alone. Lines connect each participating entity set to the diamond. These lines. Like we can give it some names like takes, teaches, borrows, manages. So use always a verb to give the names to relationships. So entities, they are nouns basically. They are nouns, and your relationships, they are verb. I hope you got some idea. Yes. Now see what happens. I want to discuss this part also with you. So what happens in this one? Here, if suppose yes, one more thing before discussing this part. This topic is a part of our lab course also of DBMS, and definitely there will be some viva questions at the end of the semester when you will be sitting in the external exam, and also during the internal exams. So what is the main thing which can trap you during viva, that I wanted to discuss. So here what happens is, so what questions embarrass students in Viva is, uh, suppose Ravi scored 85 marks in DBMS. Okay, so which entity does marks belong to? Either matlab means whether it will belong to a student because it is marks of a student, or whether it belongs to the course because it is marks of the course also. Yes. So think about it. So Ravi has some marks in DBMS, different marks in maths, different marks in data structures. Marks is not a property of Ravi alone. Correct. Then is it a part of course? No, because DBMS gives 85 marks to Ravi, 92 to someone else, 71 to someone else. It is not a property of the course alone. So I utilize this word alone. So where will this marks go? So marks will become a property of a relationship. A relationship. So because this marks, it belongs to the pair. Ravi takes DBMS, the relationship itself. So we hang the marks ellipse of the diamond, not of any rectangle. So that's why it became the property of relationship, an attribute of the relationship. So just like we discussed, there can be some attributes of an entity like name, age, yeah, address, in this way, and which can be represented with ellipse. I hope you remember this part, how to represent attributes, and different types of attributes also we have already discussed. Now marks, because it can be a part of student also, and it can be a part of course also, but it is not a part of both of them alone. It belongs to both entity sets. That's why we will say marks attribute is a part of the pair. Okay, so marks will belong to which portion of the ER model? It belongs to the relationship. Great. So I hope you understood this part. If you have any doubts, please drop a comment. Let's go further. Yeah. So our next main portion about relationship is degree of the relationships. How it happens. How it happens. Okay, how we represent these relationships. Okay. So there are different ways. First one is unary, second one is binary, third one is ternary. Degree 1, degree 2, and degree 3. Okay. Okay, we will see them one by one. And before that, I would like to tell you that some examples are already given here. Like suppose I am mentioning that employee manages employee. This is one example. We are going to take it in detail right now, one by one. Okay. For binary, student takes course. So you can just remember one thing. Here I have taken only one entity set. Employee manages employee. Here it is taking only one entity set. Binary, it is taking two entity sets. And in ternary, doctor, medicine, and patient. There are three entity sets. These three are entity sets. Okay, great. So let's see one by one. For now, just remember this and let's draw them one by one. What are they? Yes. So first one is unary. Unary, it is also called as recursive. First thing to remember is it is also called as recursive relationship. Okay. A relationship from an entity set to itself. That means employee is having relationship with itself like this, which is mentioned over here. Right. So employee is connected to employee or to itself, you can say. Okay. Because we mention always the rectangle with entity set, not one particular employee. So here we are talking about all the employees. It is a set. It is a set of employees. So set of employees, the employee can be a manager also, employee can be a worker also. Now I hope you are getting some idea. What is the meaning of recursive relationship? So it will, so it's like your manager is also an employee. The worker is also an employee. Correct. So same rectangle, but two lines going to the same diamond. So here employee manages employee because lines come from the same set. So we label them with roles. So here we are talking about manager and here we are talking about a worker because we are talking about a recursive relationship, a relationship with itself. That's why with the lines we have to mention some roles to get some clarity in the ER model. Okay, so let's see. Suppose closer to your home, your class monitor is a student who manages students. So course is a prerequisite of course. DBMS requires data structures. Both are courses. So a person married to a person, one set, talking to itself. These all are your real-time examples that you can remember for unary relationships. Fine. So this is one of the viva questions also that your examiner can ask, in which students get sometimes they get confused. So let's move further to our next type of relationship, that is binary relationship. So it contains two entity sets. So here you can see it is having two entity sets, student and course. So you can think of certain matlab that this one we have already taken up many times, and it is simple that we are working from the starting in ER model. There are two entities, student and course, or you can think of different entities like this, customer and order. What is the relationship? Places. Customer places an order. Author and book. Author writes the book. Professor and course. Professor teaches the course. Passenger and ticket. Passenger books the ticket. So you can think of these certain ideas. And honestly, I would say this is 95% of everything you will ever draw in exams and in industry. If degree is not mentioned in the question, assume it as binary by default. Okay. Yeah. So it's becoming more interesting when we are reaching towards, drawing the complete ER diagrams full fledged with all the functionalities. Let's go with the third one, that is ternary relationship. So what happens in this one? As I already told you, it will be a, relationship between three different entity sets. Three entity sets are connected utilizing one diamond. Okay, let's see how it happens. So a doctor prescribes a medicine, one relationship, and doctor prescribes this medicine to the patient. Yeah. So here is the subtle point, which can come in your exams for 5 months directly. Why not just three binary relationships: doctor patient, medicine, and patient medicine? Because think of it, why we cannot represent it as, three different relationships, three binary relationships: doctor prescribes medicine, doctor treats patient in this way, and patient and medicine, patient takes medicine. In this way also, we can make three different binary relationships. Now, why this happens? Okay, we are using this ternary relationship in which three sets are being used. Okay, so because the meaning lives only in the try, the actual meaning will be dictated when we will use it as a try. Yeah. Hmm. So suppose you can think of any doctor, a doctor prescribed, suppose any medicine to someone, a patient, and that patient received that medication as a medicine, and prescribed by whom? By the doctor. Only who prescribed what to whom? All three together captures this prescription. When you will try to break it into different, binary pairs, your information will be lost. So that is the key point of this questions, which becomes confusing during exam sometimes. Okay, why this ternary relationship is required? So that with the trio we can generate a meaningful information through the ER model. Yeah, great. Okay. Now the thing is, a ternary relationship cannot be decomposed into binary relationships without losing information. Some information will be lost. So that can be your answer in your exams. Okay, so let's move further quickly to the next one. Now, what happens is, this is the one thing that you have to understand very, precisely, and give it some time and listen to this part of the video carefully. Okay. Now see, the part interviews are made of, mapping cardinality. Not just are they connected, not just ke we are thinking ke in just one thing ke how your entity sets are connected. Is it enough? No. The real question is how many y's for one x and how many x's for one y. Okay, how many on each side? That means how many students are connected to how many courses in this way. So you can think of any two entities, yeah, like a student and a course that we are discussing since starting. And now we have to think how many students, how many courses, that will decide many things. Okay, that is called as cardinality, mapping cardinality of the ER model. Okay. So you have to think in this way. This is one sentence to remember. Please make a note of it. That is, how many y's for one x? That means you can think it like this. There is x, there is y, and they are connected with some relationship. So how many y's are required for one x and how many x's are required for one y? So that will help you out to decide which cardinality we have to use in this ER model and between the relationships. That is the thing. So let's see, there are different categories in which cardinality is designed. One-to-one relationship, one-to-many relationship of cardinality, and many-to-many. So one-to-one is represented with the ratio 1-1. One-to-many is represented 1 is to n, and many-to-many is m is to m. Let's explore them one by one. What are they? And let's see. So first one is one-to-one relationship. Suppose we have two entities. One is person, another one is Aadhaar. So that is the one of the very good examples of one-to-one cardinality. So one person will have only one Aadhaar card. Correct. One will have only one Aadhaar number also, you can say. So that is an identity of a person. So one person's identity cannot be taken by another person's. They will always have, one person will have only one Aadhaar. One Aadhaar will belong to only one person. So how many X and how many Y? So how many Ys for X and how many X's for Y? So only one person, one Aadhaar card for one person, and one person will have only one Aadhaar. Correct. So that is the thing. So in this way, you can understand one person will have only one Aadhaar. With sets also, you can understand this part. Okay. So one person cannot have two Aadhaar, two identities. One Aadhaar cannot belong to two people. So this is a straight pair, no branching. I hope you got some idea. This is called as one-to-one cardinality relationship. Let's see next one. That is one to many. So in one to many, what happens is how many x's for y and how many y's for x. So here also again we'll check in the same way. One entity set is department, another entity set is student. Okay. So how many, we have x and we have y. How many y's can belong to one department? Many students can belong to one department. Yeah, but one department cannot belong to many students. Yeah, one department can have many students, and many students can belong to one department. Okay. Or you can think it in this way. One student can belong to one department only. Okay. But one department can have how many students? Many students. One department will not run with one student only. Okay. So one department can have many students, but one student can belong to only one department. So in this way, you can remember. Okay. So this becomes our set diagram. One department can have many students. That is one to many relationship. Great. So let's go to the next one. That is many to many. I hope you are getting some idea. Now you can assume also, you can pause this video and you can go back a little bit and you can think of many to many cardinality. So here what is happening? We have two entity sets given here, student and course. So suppose how many courses one student can take? Many courses. How many students does one course can have? Many students. Yes. So that makes the sense. How many x's for y? How many y's for x? Okay. So here once one student can belong to many courses. One student can belong to many courses, and one course, that's why many came, and one course can have many students, that's why many came. Great. I hope you got some idea. So here one student is related to many courses, and one course is also having many students. Okay. So I hope you got this part. So many to many relationships, it is the most common cardinality which has been asked in the exams. And when in a doubt, you can have different examples on this, like student courses, doctors, patients, actors, movies. They are usually n is to n relationship. Okay, great. So that is all about our relationships. And let us assemble everything together now. Our entities, attributes, relationships, and cardinality. That becomes our labeled ER model. Okay. So here you can see all the things that we have discussed so far about ER model. We have entity sets, two entity sets. We have attributes of entity sets, course ID, title of course, roll number, name of, and in this one type of attribute, that is key attribute, is shown with the entities to identify them uniquely. Relationship is shown, takes, then one attribute of the relationship is also shown in this one, and then the cardinalities are shown. Great. So this is binary relationship, and cardinality is many to many, and it is having different types of attributes and the entities present. Great. So that makes our ER model. And now it's your turn. Correct. So I'm giving you this question. Pause this video and note down this question. A member borrows a book. Record the borrow date for every borrowing. Draw the ER diagram. What shapes you will utilize? What is the degree of the relationships you will utilize? What is the cardinality you will utilize? And where will your borrow date goes in your library system? So that is one ER model you have to create for library system. So pause this video, take your time, draw this diagram, draw this model in your notebook, and that is our simple answer, which is combining all the things. Correct. So it is showing different entities that is being taken for the library system. That is, one is member, one is book. So member is one entity set, book is another entity set. What is entity? Entity is which is having some real world existence and which is distinguishable from other types. Yeah. So book is the one. And with this, you can draw some attributes also. If you have already drawn, that will be very good. Okay. So member will have its member ID, book will have its book ID, book name, author name, okay, which edition it was. So these types of attributes you can create. Then relationship is borrow. So member will borrow a book. Really, one member can borrow many books, and one book can be borrowed by many members. So relationship is cardinality is M is to N, and borrow date, because it belongs to both member and book, that is pair. So it goes as an attribute of relationship. So that is the thing. Great. Now, from the exam point of view, I have noted some questions for you people that you can make a note of, which you can remember in your mind to prepare for your exams. Like explain mapping cardinalities with suitable examples and diagrams. It can come for 5 marks. It's all about your different types of cardinalities. Degree of relationships, unary, binary, ternary, with examples you have to explain. It can come for 5 marks. Define relationship set with an example. What are descriptive attributes? Okay, like where does marks belong? That is your descriptive attribute. So I hope you got this complete idea about relationships in ER design, and I am closing it here, and I will close it with a question for you for the next lecture. Department has many students, yeah, but can a student exist without a department? Think about it. And can a course run with 0 students? Think about it. So you will get some idea that some entities cannot survive alone. So please give your answers in the comments, and thank you for watching this video. Your comments, your subscriptions, it's such a motivation to me to keep running my channel. Thank you again. See you in the next video. Bye bye.